lesson, Algebra 1 of Chapter 5, 5.6, is we are going to graph inequalities. Now, we're not going to graph them on a number line, we're going to graph them on a two-dimensional graph, the xy plane. So now we're going to introduce x's and y's into our problems. So, the first thing we have to remember is that you still have greater than, you have less than. And those are open dots, right? So we have open dots. Or when we go to graph a line, because I cannot be there, they're going to be dashed lines. While greater than or equal to, less than or equal to will be those solid line dots when we're on a number line. And in two dimension, they are the actual line. So when we graphed y equals, they were equal to the line, that's why we had a solid line. So now we got to watch out. Is it open or closed or dashed or solid lines? Now I have some steps here for graphing inequalities. Number one, some of us, we like to change our inequality to an equal sign. Now I added that there. I generally don't like to necessarily do that, but a lot of students get that kind of mixed up with, that doesn't look like slope-intercept form, it doesn't look like standard form because there's no equal sign. When they really, in fact, you can treat it just like an equal sign. So maybe instead of change the inequality to an equal sign, treat the inequality sign as an equal sign. I need you guys to, number two, plot the points of the line. So find those critical points. If it's in slope-intercept form, right, so y equals mx plus b, then you know the slope is m, the y-intercept is b. Plot those. Plot a few points. If it's in standard form, so ax plus by equals c, then you can use your cover-up method and find your x and y intercepts. You can use those. That's awesome. Those are the two that we're probably going to use today. And then in 3, you got to decide, is this a solid line or a dashed line compared to what those are up here. And then once you've dashed your line or solid your line in between those critical points that we found using this information, you are going to then pick a point, usually 0, 0, and then you're going to shade the side that works. So again, if it doesn't work, shade the other side. First, our examples for the graphing inequalities, I got one of each. I got one that's in slope-intercept form and one that is in standard form, and we'll graph both of these inequalities. So, here's the cool thing. This is already in slope-intercept form, so I know that my slope is 1/2 or up 1 over 2, and my y-intercept's at 3. So if I go to make my graph, I know I start at my y-intercept, which is at 0, 3, and I'm going to move slope. Now, remember, you can move slope in the forward direction and in the negative direction. So I am going to start at 3 and go up 1 over 2. So I end up being about here. We also know that I can move slope in the reverse direction, which means make them both negative. Negative 1 and negative 2, because negative makes a positive. So I can go down 1, back 2. Now, if you do your tick marks, right, all these little marks here, to be really consistent, those will form a straight line. I have to ask myself, what is this going to be? Solid or dotted? You're like, oh, that's just a greater than. I cannot be on that line, and so I end up being a dotted line. Now we're all up to the last step. I just have to check a point. Now the point that I like to check is 0, 0, especially when working with multiple variables, because that means I'm going to plug a 0 in for y, and I'm going to plug a 0 in for x. And anytime you put zeros in for things, if I'm multiplying to them, they're gone. And so I get 0 on the left side, this is gone, and then I get 3. Is 0 greater than 3? No. So if 0 doesn't work, none of these points down here are going to work. I have to shade up. So anything above that line are solutions. There's an infinite amount of solutions, That's how you would do those. The next one is in standard form. I like standard form actually a little bit better than slope-intercept form when it comes to graphing lines, because then I'm going to use my cover-up method. Remember in the cover-up method when we did this, you put 0 in for x and you put a 0 in for y separately, so that when I put a 0 in for x, I can cover it up. And then I'm asking myself, what is 3y equal 18? Divide both sides by 3, y has to equal 6. I do the same thing, put a 0 in for y, it's gone. When does 2x equal 18? X has to equal 9. So now, that's my y-intercept. This is my x-intercept. Plot it. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. And now I just have to connect those two dots with a line. Looking here, solid or dotted? It is solid. So I go to connect them with a solid line. And here's the cool thing, I'm going to test that 0, 0 again. And the really cool thing about 0, 0 in this case is that this is 2 times 0 plus 3 times 0 is greater than or equal to 18. This whole entire side is just going to go to 0. And is 0 greater than or equal to 18? And you would absolutely say, absolutely not. So therefore, I have to shade away the side that does not include the 0, 0. So any point out here is a solution to these guys. Your homework is just to graph 6 different inequalities. Make sure some of those are in standard form, some of them are in slope-intercept form. Find your critical points, solid or dotted, check a point, and shade. Have a great day.